Hello everyone. In this video, we shall learn about conjugate acids and conjugate bases. We have studied about the Bronsted-Loring concept and Arrhenius concept. In this video, we will learn about the conjugate acid and conjugate base. And conjugate acid and base, it is a very simple concept. And acid and base pair which differ by proton is called conjugate acids base pair. Suppose you have a HCl when undergo dissociation, it gives H plus and Cl minus. HCl is a strong acid. So this strong acid gives a weak conjugate base. This is a weak conjugate base. So this acid and this base, it is differ by this proton only. So such kinds of pair are called conjugate acid and base pair. For more understanding, always remember either, since you know that you have a strong acid and strong acid, since you know that acid has a both strong and weak, strong acid and weak acid. Base also have a strong base and weak base. Strong acid, like you have HCl. So suppose you have a strong acid. The note number 1 is strong. Any type of strong acid always give weak conjugate base. So strong base will give rise to weak conjugate acid. Similarly, weak acid will give strong conjugate base, and weak base will give strong conjugate acid. So suppose you have a reaction CH3COOH, that is acetic acid. Acetic acid is a weak acid. So weak acid will give what? Strong conjugate base. Let's see. When weak acid undergo reaction with H2O, you get H3O plus CH3COO minus. This negative charge will go and attack this proton, and this bond will break Let me write in this way. Suppose you have a CH3COO minus H. This is not minus, bond H, plus H2O. Since this bond will go and attack this bond will break and it become like this. And you will get this. So by this reaction, this is an acid, weak acid, and this behave as a base, and weak acid give strong conjugate. This is a base, conjugate base, and conjugate acid. It is slightly acidic in nature. Another type of example is, suppose you have a H2O when undergo reaction with the ammonia. Since we know that nitrogen has a lone pair, 5 valence electrons, and it has a 1 lone pair, 2 free electron. This free electron will go and attack these hydrogens and the bond will break. And you get, suppose you have HOH plus NH3. This lone pair will go and attack this and this bond will break. And you get NH4. When electron is scanned, it becomes positive charge plus OH minus. So out here also, this water will behave acidic character, and this ammonia is a base, and this ammonia become acidic, conjugate acid and conjugate base. Similarly, when HCl is react with H2O, this is just a repetition, you get H3O plus Cl minus. This is a acid, strong acid. This strong acid will give weak conjugate base. So this strong acid will give this weak conjugate base, and this will give this. Base will give conjugate acid. This is conjugate base. So these are some example of strong acid and strong base. HCl, hydrogen iodide, is also a strong acid. HBr is also a strong acid. Strong base are sodium hydroxide, potassium hydroxide. Weak acid are like you have CH3COOS. CH3COOS. This is acidic acid, is also a weak acid. Ammonia is a weak base. Ammonium hydroxide is also a weak base. Aniline is also weak base. Suppose you have another type of example is, suppose you have a cyanide. When undergo reaction with H2O, cyanide is a base, water acts as a acid. When this react, this cyanide, it has a negative charge, it will go and pick up this hydrogen, and HCN will get, and OH is break and form. So this cyanide, it is a base. This base will give conjugate acid. This is conjugate acid, and this water acidic will give conjugate base. So in the nutshell, Suppose you have a compound. Example, if you are asked to find out conjugate acid and base in the compound like H2SO4. Suppose you have given this compound and you are asked to find conjugate acid and base. You have to go some reaction, but to find out the trick number one is to get a conjugate acid. Suppose you have this compound, if you add 1H extra, 1H plus extra in given compound, then you get the conjugate acid. And to get conjugate base, you eliminate 1H. So what you will get in H2SO4 minus conjugate acid is, if you add 1H, H3SO4, since it has added 1 electron, this negative charge will reduce. And if you have this compound and conjugate base will be, if you remove 1 hydrogen, you get HSO4. Since 1 electron has been lost, so it will become, negative charge will increase to 2 minus. So in this way, the conjugate acid and conjugate base can be easily identified. These are some of the acid and base. These are the conjugate base and acid. You can go through. In this conjugate acid, HClO4, but in base 1H has been reduced. Similarly, HCl, you have H has been reduced, and since 1 electron is lost, it becomes 1 negative. Suppose this hydronium ion H3O plus was a conjugate acid. So conjugate base will be H1 is, if 1 hydrogen is removed, H2O. Since it is negative, it is positive, so it reduced, it has been lost. So in that way, you can go through this, some example and practice. So this is all about the conjugate acid and conjugate base.